Hello and welcome, everyone. My name is Mark Henry. I'm a senior engineer with Opmantek's North American office located in Charlotte, North Carolina. Today, we're going to talk about a really interesting topic, how to take NMIS's built-in SNMP and WMI collection and expand it through the application of collection plugins. So like all of our webinars, if you're attending the live webinar today, we will be sending you along a follow-up email with a link to the recording. If you have any questions during the webinar, please submit them using the chat window or the Q&A window, depending on which version of GoToWebinar panel you have. And of course, once you exit at the end of the seminar, or if you have to leave early for some reason, you'll be presented with a very short 3-question exit survey. Please take a moment and complete that. So we like to kind of map back all of our webinars back to Gartner's IT Service Management Maturity Model. And being able to expand on kind of any monitoring solutions, built-in monitoring rules or monitoring system, really allows you to expand the capability of your network monitoring, your server monitoring, and be able to hone in on features and functionality that actually drive business decisions and business outcomes for your IT group and for the customers that you serve, whether those are internal lines of business or external customers if you're operating as a managed service provider. Today's seminar will focus in on Opmantek's free and open source NMIS platform. NMIS works as the core fault and performance monitoring solution for all of Opmantek's commercial products. A few useful references for you. So we've included in links here for the NMIS wiki, for the plugins documentation, which is what we're going to cover today. NMS modeling, how NMS models are designed and built, and how you can adjust those models or build ones for yourself for new devices, and also how thresholding works, which is the concept of kicking off events or alerts and alarms on rising or falling thresholds or loss of services. If you have any questions, we also have a questions board that you can post questions to. If you are a support customer, though, feel free to email us at support@opmantek.com with any questions. We'll be happy to help you out. So without further ado, let's get into NMS 8 plugins. So why the concept of taking a plugin approach to things? So there's really a few different patterns that apply to this. So there's the concept of being able to cross-link data in NMS. So the idea of having, let's say, a host server, a VM host, and the VM client devices, and being able to add links in between those devices. You might want to be able to look up and beautify data. So you might want to take abstract numbers and turn them into kind of the understanding of what they are. So for example, a lot of devices store numerical values that mean something, that translate into a word or a phrase. And so being able to take those numbers and translate them into something that is human readable, really. Also collecting arbitrary data not from SNMP. So being able to pull information out, be able to store it, and you might be reading an XML file. You might be taking in an SNMPTrap in addition to SNMP. You might be reading from some kind of a syslog or a data log. You might be reading from a database. You might be connecting it through an API and executing commands. You might be executing commands from a CLI interface as well. So for example, you might have a router and you want to connect via SSH, execute a CLI command, return the result of that CLI command back, parse through that data, pull out a specific set of information from that, and then add that to NMIS. It might also be something that you want to be able to handle really complex SNMP queries. We found cases where manufacturers have really encoded information. They've converted data into hex. They've stored it as a long string of information, and you need to find the 14th set of hex characters and translate those from hexadecimal back into back into binary or back into decimal format, and then you might want to do some math to that and then do something with that information. And then, of course, there's always the opportunity to do some weird stuff, right? And that is a technical term, weird stuff, which can only be resolved by writing some code. So the NMS modeling system is really very, very flexible, but then it's not designed to be a full-fledged programming language. So when you need to get beyond what NMS can do inside the NMS modeling system, think about and look into NMS plugins as an opportunity. So a few things to kind of think of. NMS plugins are broken up into two different options. One is to run during the update cycle, and the other one is to run during the collect cycle. So NMS updates run, generally speaking, once a day, and they gather static and non-performance related data. Think of it like interface descriptions or device names, things that don't really change often. And so you don't need to gather that information every time you do a poll, a performance data poll, or a collection from that device. The second piece that you can extend is you can actually extend the collection system for NMIS as well. So the new collections. So the NMIS collection scheduler runs once a minute. It uses the assigned polling policies to determine the frequency of how often collections run. So you can create NMS plugins that run either following a collection of a device or following an update of a device. There are 4 classes of NMS plugins in all. Collect plugins and update plugins. Again, they run once for each node during those appropriate times. And then you have an after collect plugin and an after update plugin. Those actually only run once at the end of the operation. So if you're running an NMIS update on a lot of different devices and you need something to be able to process against all of the data, you would run an after update plugin. All of your plugins are stored in the NMS8/conf/plugin folder. We ship with about 30 different plugins already built into the system that are already being applied now, depending on the types, models of devices you have, and also the types of Opmantek applications that you have licensed. So there are some basic rules and restrictions that apply to all NMIS plugins. Each plugin must be written in valid Perl. That's really important. We've had people ask before, oh, well, can I write them in Ruby? Can I do them in PHP? Unfortunately, right now, no, you can't. They do have to be written in Perl to be consumed by NMIS. The plugins must be named something.pm, so it must have the .pm extension on it. Internally, within the code of the plugin itself, it must include a package X line. So again, whatever name you give the plugin. So if I call it widget.pm, internally I'll have to have package widget as a line within the code. It should be one of the first lines. We'll show you an example in a minute. The package name must not clash with other NMIS components, and this is vital. So you can't take an existing NMIS component, copy its name, and use it as a name for your plugin. You should also not repurpose the names of any NMIS models or NMIS graphs. So even if you're writing a plugin specifically for a specific to work with a specific model of device, let's say checkpoint devices, you don't want to copy, for example, the name model-checkpoint.pm and use that for the name of your plugin. NMIS won't like it. You'll end up with an error and it will not process that file properly. The plugin must also not use exporter to export anything from its namespace. So you can't send anything outside of the plugin. And finally, you should include, of course, a version declaration right after the package line. NMIS will actually capture that version declaration and store that in the logs so that you'll know which version of each of your plugins are being executed at what time. These are a lot of rules, I know. We're going to touch on these in a minute when we actually start looking at some code. So let's talk about the concept of collect plugins and update plugins, right? So the way these work is they're actually called for each node in sequence. So as an individual device, when a collect sequence or an update sequence runs on an individual device, NMIS will call collect plugins for that device individually. So it'll actually run in its own memory space, potentially as a separate process. It'll run independently to other processes that are operating at the same time. They do run only at the end of a collect or update operation. So a collect for a device will run first, and then NMIS will load into memory all of the collect plugins, determine which ones have to run, and then apply those, whatever those functions are that you've created. An important note here is that all existing valid plugins are loaded and all available functions are applied to every node, regardless of success or failure. So we're going to show you a couple examples on how to build kind of application rules so that your plugins only work on the devices you intend them to, and so that the plugin doesn't fail but exits quickly, rather than processing through needlessly on a device that you're not necessarily applying changes to. An important thing to understand is that plugins can modify any node attributes where required. Again, so that's a collect plugin and an update plugin. What you can adjust when you use an after collect plugin or an after update plugin changes slightly later on. We'll go into that. So let's take a quick look at a couple of different examples here of update plugins and collect plugins. And again, both of these ship with NMIS now. It's on our VM already, or we'll install with it. So let's take a look at the checkpoint. So this is a collect plugin. I'm just going to scroll back to the top here. So you can see that we have the package line, so package checkpoint, and that this matches the name of the file. So the file name is checkpoint.pm, so the package is checkpoint. We've included a version statement, and there's a minor version upgrade, and you can see that I've added a notation there on when this upgrade came. So we're importing a couple internal NMIS functions, so we can actually consume NMIS information. So we can pull information in, but again, anything that we change can only be related to the nodes themselves. We can't export any information out, and we can't change any global variables from inside here. Everything that we work with here internally has to remain internal to the plugin itself. Then we have our function, sub collect plugin. So you'll notice now that the name of the function, in this case, collect plugin, here in the Radwin one, you'll see a sub update plugin. This format is a required format. So when NMIS loads the plugins into memory, it actually separates all of the collect plugins, the update plugins, the after update, the after collect plugins. It separates them all, stores them in memory, and has them available to run back to back and be applied. In this example, we're loading the arguments. So NMIS will call this checkpoint.pm, and it'll pass a list of available arguments. Some of those available arguments you can see here, we're passing the individual node, so the node table, the sys table, and the config table. So we're making those three things available immediately to this function, and then we're loading them and we're storing them into three variables: $node, $S for sys, and $C for config. You can absolutely rename these variables if you don't like that. You can see here that we're pulling in from the sys table again. So from the sys collection, we're pulling in node info. We're storing it in $NI. And then we're doing a quick test. So here we're saying return 0. So we're going to exit this routine, return 0 if the system model is not checkpoint. So if this device is not assigned to the checkpoint number, or if this device is not marked for collection. So inside NMIS, you may have a device loaded. It may be assigned to checkpoint model, but if collect has been turned to false, then we're not going to run this. We're not going to run this at all. We're going to exit from here, and we're just going to stop processing. And that's important that you have this type of a test early on within your plugin, because you want to make sure that your plugin is only applied to devices and situations where it's applicable. So now this this plugin happens to go through. You can actually open this yourself again, but it goes through and it processes several different types of alerts and informations based on these checkpoint type devices. It preloads information that's going to be displayed on the device details panel. It even color codes information, so you can see, for example, down here, we're color coding information. So we're leveraging the power of an HTML-driven GUI by color coding devices. We can even add CSS to it. We can add some styling to these pieces as well, and really be able to, again, kind of beautify the NMIS interface and point information out. Another example that I'd like to show you is an example here from Radwin Wireless. Now this one is for Radwin Wireless devices. So you have both a Radwin Wireless base station and then a kind of a consumer or client-focused receiver and transmitter unit. So imagine a wireless router on your building roof, and that's transmitting out to receiving stations around town. And what you want to be able to do is you want to be able to provide a reciprocal link inside NMIS. So if you're viewing the device details for the base station and it lists, let's say, 20 receiving devices, you may want to provide a link from that base station to each of those individual device details panes. And so what we do here again is we're showing package Radwin Wireless. Again, the name here, the package name, is the file name less the .pm extension, the version number. We're loading a couple internal NMIS functions so that we can have access to configuration tables and some NMIS timing pieces as well. We're loading those arguments again, so we're having access to the node-specific information, the system table, as well as the configuration table. And then we're doing that initial test. So we're looking for, specifically, for a specific entry within the node info. So we're looking for an entry of HBS, and if it's not equal to a hash, then we're going to exit with a return of 0 and undefined content. We're setting changes were made to 0, and you'll notice later we're going to do a test down here at the bottom. So we'll say return changes were made, undefined. So if changes were made, that gets changed to a 1. So that's a return status of 1, and we'll talk about what the acceptable return statuses are. There are 3 actual acceptable return statuses. Either 0, so you can see here return status of 0, which means it exited with no changes. A return status of 1, which means there were changes, and those changes should be written back to the node table. And then the third option would be a return status of 2, followed by any error information or defined error text that you want to return back. So in this case, again, now we're going to loop through the information that we found. We're going to look for specific information. If we find a name that matches, so if we are on, again, if we're on that HBS unit and we find the client unit, what's called an HSU, if we find a client unit, then what we're going to do is we're actually going to create a very long URL, which gives us lots and lots of good information. So it actually makes the URL an actual active link. All right, let's go back to our PowerPoint presentation. Again, just a couple of examples. Again, we ship with about 20 different plugins pre-built, all ready to go, already being processed, adding to the NMIS interface, the NMIS enrichment. So valid return values. Again, this is for collect plugins and update plugins. A 0 or undefined. The rest of it is ignored. No changes are made. A 1 means changes were made to the sys object, and NMIS will save the node info and view components. So that's important. So returning a 1 tells NMIS to save those changes. A 2 followed by a list of error messages means the plugin failed to work, and NMIS should log the error messages, and no node info or view saving will be performed, and that's an important piece. So now the after collect plugins and after update plugins, right? So again, these are called once at the end of the respective operation. So while a collect plugin and an update plugin are called every time a collect is run on an individual node, the after collect plugin and after update plugin are only called once at the end of a collect cycle or an update cycle. It's important to understand that there is no node context available to these plugin functions. So while it understands kind of the gross information about nodes as a whole, you don't really have an individual node context to work with. Just like collect plugins and update plugins, all valid plugins are loaded and all available functions are run in sequence. So an example of that is the interface export PM. Let's take a look at what that one looks like. So again, we start with the same piece, package interface export. And again, that is the name of the file less the .pm extension, the version. You notice we're not loading the use NMIS function at this point. We're just loading function to get the access to log message. In this example, we're actually loading an external program. This is a part of OP charts. So the concept here, the understanding is that OP charts is installed and is available. So if you've licensed OP charts and it's there, then we have the name of the actual function. So sub after update plugin, and again, NMIS is looking for this queue. So these function names must match either after update plugin, after collect plugin, or update plugin. The actual functions inside these files have to be in this format because NMIS is looking for that in order to determine which of these to run at which point. We're still loading some nodes here. Now notice that that this is now plural. We're loading nodes, not just node. So we're loading all nodes at once, along with the sys table and the config tables. So here's a nice example of a Perl shortcut. So we're saying if this file exists, if export program, so if this file exists, so if OP charts has been installed, so if you've done a custom install of NMIS and not installed OP charts, then that program will not exist and this function will exit at this point. And you'll notice here, if that fails, then you'll log a message warning interface exporter could not be found. And that's important to understand. If you've installed OP charts in a different location, in this example, we're using kind of the default location. We're hard coding it in here. So if OP charts has been installed in a non-standard location, you would have to fix this, right? So you'd have to actually go into this plugin and adjust this hard-coded path to point to the correct export program location. And then here we're building out arguments. So we're saying use export program, act equals import interfaces, quiet equals true. We're building out some additional arguments here. And then we're looking for the result. So we're getting back a specific result from this run. And we're going to log that as well. So again, just an example here. So if everything kind of doesn't work right, we end up back down here. So at the end, we're still doing a return 0 because we don't need to save anything. We're actually just using this opportunity to kind of kick off that every time an update is run, that we're going to run this import interfaces piece, make sure that OP charts is updated and has all of the interfaces that are available in all the devices. And we don't need to update anything back into NMIS. So we're doing a return 0. And you'll notice the last line down here is simply a 1. That allows us to exit this this subroutine and return control back to NMIS. So valid return values, so much like what we were looking at in the collect plugins and update plugin piece, 0 or undefined means no changes were made or that the plugin declined to run altogether. One means changes were made to the sys object, NMS should save node info and view components. And 2, with a list of error messages, means the plugin failed to work, and NMS should please log the error messages. No node view or view saving will be performed. All right, well, that concludes today's webinar, an introduction to expanding NMS's collections using NMS plugins. I hope you found this of value. If you have any questions, again, you can go to our questions board. Feel free to email me directly. I'm markh@opmantek.com. We'd be happy to help you out and answer any of your questions. Thank you.